What happens when a mountain moving at 20 times the speed of a bullet collides with our planet? This is a simulation.
The energy released in this moment is greater than the entire nuclear arsenal of humanity combined, millions of times over.
But the greatest threats sometimes don't come from the outside, but simmer right under our feet.
We will explain how a man-made device could generate an artificial seismic event, shaking the entire planet.
To understand the scale of destruction, first, we need a yardstick. Let's begin our journey with Every conventional explosion follows a fundamental principle: rapidly breaking chemical bonds to release energy.
But what happens when this chemical limit is pushed to its maximum in an unforeseen accident?
A spark. That was all that was needed to begin the chain of events leading to the largest man-made, non-nuclear explosion in history.
For 20 minutes, the ship became a giant, ticking time bomb, drifting towards a crowded pier.
At 9:04 a.m., 2.9 kilotons of TNT equivalent energy were released almost instantly. The heat of the explosion reached 5,000 degrees Celsius, vaporizing the water in the harbor. This pressure wave flattened more than 2.5 square kilometers of the city.
The explosion was so powerful, it temporarily exposed the harbor floor. Immediately afterward, a tsunami scoured what was left.
Debris from the explosion was found kilometers away, a testament to its incredible power.
Halifax had shown the limit of chemical energy. To go further, science had to break another barrier.
That barrier was the atom itself.
Einstein's relativity showed that a tiny amount of mass could be converted into a tremendous amount of energy.
Humanity was about to step into a new era of power. The era of fission. The New Mexico desert, 1945. This was not just a weapons test, but a large-scale physics experiment.
The goal: use a conventional explosion to compress a plutonium core to a supercritical state, initiating a chain reaction.
In a millionth of a second, the plutonium sphere was crushed to half its original size.
It was a sunrise no one had asked for, a light that cast the longest shadows in human history.
Scientists calculated the bomb's power by measuring the expansion speed of this shockwave. The intense heat fused the desert sand into a new type of mineral, a geological footprint of the nuclear age.
The experiment was a horrifying success. The power of the universe was no longer theoretical.
This technology was quickly weaponized. The Fat Man device was an improved version of the Trinity design. Nagasaki's unique terrain partially contained the blast, a grim lesson in the interaction between energy and environment. The intense thermal radiation left ghosts on walls and pavement, haunting images of the energy released. Despite its power, fission is a relatively inefficient process, converting only a tiny fraction of mass into energy.
To create an even bigger explosion, scientists looked to the opposite process. Not splitting, but fusing. Nuclear fusion is the process that powers the sun and the stars.
The race to create a sun on Earth had begun.
This was not a bomb, but a thermonuclear factory. Ivy Mike, the first test of a thermonuclear device. Its design was incredibly complex, using a fission explosion to create the temperature and pressure needed to start a fusion reaction. The explosion released 10.4 megatons of energy, more than 700 times the Hiroshima bomb. Where an island once stood, there was now only a deep, underwater crater, nearly 2 kilometers wide, and 50 meters deep.
Humanity had taken a quantum leap in power. The unit of measure was now the megaton. The next challenge was to miniaturize this technology into a deployable weapon.
Castle Bravo was expected to produce an explosion of about 6 megatons. But the scientists had made a critical error. They had underestimated the reaction of a lithium isotope, causing the explosion to far exceed all calculations. The result was a 15 megaton explosion, more than double the prediction. A monster had been unleashed beyond control.
The aftermath was the worst radiological disaster in US testing history. On the other side of the world, the Soviet Union decided to make an ultimate statement of power. The Tsar Bomba.
The original design could have yielded 100 megatons, but it was modified to 50 to reduce fallout. A relatively clean bomb. Even with the reduced yield, the bomber crew had only a 50% chance of survival.
It was an explosion that refused to touch the Earth.
The shockwave from the blast caused the plane that dropped it to plummet over a kilometer.
The explosion generated a seismic event measuring 5.25 on the Richter scale. More incredibly, its atmospheric pressure waves were recorded circling the Earth 3 times.
This was the absolute pinnacle of man-made explosive technology. Humanity had proven it could create its own tempests. But compared to the power of the cosmos, they were mere whispers in the wind.
Billions of years ago, a random event in the asteroid belt set a colossal stone on a collision course with Earth.
Its immense velocity was the key to its destructive power. Kinetic energy increases with the square of the velocity, the moment of impact. Kinetic energy is converted to heat and pressure almost instantly.
The energy released is estimated at 100 million megatons of TNT, or 2 million Tsar Bombas.
It created a transient crater deeper than Mount Everest is tall.
Trillions of tons of the planet were thrown into space. A shotgun blast aimed at the heavens.
As this debris fell back, it superheated the atmosphere, essentially turning it into a colossal oven.
The impact also triggered unimaginable tsunamis, scouring the continents. The long-term consequence was a natural impact winter, plummeting global temperatures and leading to a mass extinction.
On our timeline of power, the event was not a step.
But there is still another kind of power, a geological time bomb, the supervolcano.
The Toba eruption released energy equivalent to 1,000 million megatons, weaker than Chicxulub, but still a global catastrophe.
The key difference was the amount of material ejected into the atmosphere.
The resulting volcanic winter is thought to have pushed early humanity to the brink of extinction.
Our timeline is complete. A journey through the orders of magnitude of energy. We began with the power of chemistry, a spark in the dark.
Then we broke the atom, creating a brighter fire.
We learned to forge the sun, and the scale changed forever. Each step made the last achievement seem small. We learned that the planet's power was still superior.
The supervolcano showed that destruction isn't just the blast, but the lasting consequences.
And finally, the universe reminds us of our true place. All of this from a simple equation.
Energy from the electrons.
Energy from breaking the nucleus.
Energy from fusing the nucleus. Energy from motion.
Energy from the heart of the planet.
5 types of energy. 5 chapters of destruction.
The technology of one era.
Becomes obsolete before a new power.
And all our technology.
Point is helpless before the power of nature.
But if you look closer, this is not a story about endings.
It's also about rebirth.
Each extinction event opened a path for new life.
Our own existence is proof.
We went from
This
here.
timeline shows us where we started.
Dot to here. The question is, what lies above?
Because out there, in the quiet darkness, are fireworks that could make our sun look like a candle.
The timeline of destruction has taught us about power.
But the greater lesson is about the fragility of balance.
And that every action, great or small, leaves an echo.
We are the children of past apocalypses, living in their echoes.
The exploration has only just begun.